Joshua Letcher, thank you for coming in the middle of the night for you. I really am grateful to you for doing this. I'm going to introduce you the best I can, but you're going to have to kind of fill in the blanks. I've only, as anybody who's been watching this, a lot of these people I know for a long time. You know, some of them go back decades. Joshua is not one of those people. I've only just recently met him in the last couple months. I've been hearing about him, credit where it's due. I've been hearing about him for more than a year. He's doing some really interesting stuff in space. I'm not going to put any pressure on him, but his business plan is one of the few that actually makes some sense to me. You just heard Michael Laine say that not very many business plans make a lot of sense for the moon right now. So that's me giving him Joshua an endorsement on that. So good job on that. I don't do that very often. But there's some really interesting stuff here. So I think he's kind of the highlight of our business section of our event. So Joshua, give us a little bit of your background with a little bit of your bio before you start your presentation, please. I apologize. I've got a list of like 20 people and I don't have your bio up in front of me. So my mistake on that. Thanks. Take it away, sir.
Thank you very much. I'll share the screen because I've actually sort of worked it into the presentation. So my background is mining and resources, and I've been doing that for about 16 years. So over that 16 years, I spent the first half basically on the tools, had a 4-year gap where I joined the Royal Australian Navy as a submariner. And then the last sort of 6 to 7 years, I have been doing more ASX director and board positions and forming companies and focusing on the strategy of that side of things. So with that, I've raised north of $50 million for IPOs, for public listed companies on the ASX, Australian Stock Exchange, and built those to over 300 million market capital, which is not too bad, but I think it'll increase a bit more in the near future. My focus has been on the business strategy, innovation, and mineral resources. And then with space industries, of recent, we're looking at the space and defense side of things as well. So today I'm just going to sort of go over the commercialization strategy that we have. So the way that we've set up the company, Space Industries, and the focus is on 5 core steps, and that's spanning from the start in 2018 through to launch, which we expect in 2024. So the first step is building the foundation. Like building a house, you build a really strong foundation, and then you can build on that. To get it to the next level, you have to have customers, de-risk everything. Once you've done that, you can get traction and get investors. And then from there, you then start working on the actual product itself. So I'll just cover the building and foundations. So what I'm going to do is I'm going to basically talk to each of these with the context of space industries. So what we did is start with the problem. You can't survive without utilities on Earth, let alone in space. So basically, to choose what we were going to do in space, we decided it needs to be critical. It needs to be something that's always going to be in demand, and that's utilities. So energy, hydration for astronauts, which also couples with agriculture, and then propellant. So the solution there is to mine water. From water, you can get all of those. The next step was to see if the solution was feasible. So we got a geologist and adopted sort of Earth standards in mining and resources. So you start with a what we call as a JORC resource. So it's a report compiled based off a number of different exploration activities, drilling, soil sampling, all that sort of things. And so we did that for the moon with 2,000 also regolith samples that were taken through the Apollo missions. And then the other aspect on the feasibility side was to look at the legal implications. Can we actually mine the moon? Can you own a piece of the moon? And so with that, there's the Moon Treaty and the Artemis Accords. So that basically ticked all the boxes that we had, either a go or a no-go, and then progressed to the next side of being actual economical. So over the last couple of years, there was WGM that released a report on the lunar water outlook, and that sort of covered most of the details, things that we'd looked at during market research for suppliers, customers, demand, price, and also time frame. So time frame with the Artemis missions, we're looking at 2030. You know, it's pretty economical in terms of setting up a business and actually the right time in the industry to actually focus on producing water from the moon. If we were coming in a bit earlier, you know, the stretch line would have been too long. It might not have been economical. So on the commercial side, we had to then look at the competition, and what we did was assess globally, because it's dealing in space. It's not just here in Australia, it's global competition. We realized that most companies looking at water mining on the moon actually started out by looking at asteroid mining, and now are changing the focus to the moon, which was also a good key indicator of being at the right time. Limited competition sort of put us into a pretty good position where we could then progress and do a bit more in-depth market research. So with that, what we had to do was actually go out and speak to customers, see if there was an actual demand, see what the demand looked like, what was their timeframes, and in doing that, we realised there's about 90% of the market which is attainable. That's both looking at water and other potential resources. So in the near term, we identified that the near-term resources from the moon won't be minerals. It'll actually be gases, isotopes, mostly water, and with nuclear fusion ramping up and other medical and national security was the helium-3 side. So the priorities been changing to water, and the initial customer discussions that we've had have looked at both water and helium-3 to give a full market demand. So that was deemed to be quite feasible, and then we progressed through to the business, so to the investor ready side. So with that, we demonstrate the concept, and then we had to choose sort of how we want to proceed. So traditional raisings, do pre-seed, seed round, Series A, all the way through to Z. The benefits that has for commercialization is that it gives you strength by completing a seed round, getting non-related funds in the bank, and demonstrating that you can use them correctly and that you can actually deliver on milestones. It was quite a big task to achieve, to show investors that you're capable of then taking further money and delivering the actual mission. So track record is very important for us. The next thing that's important for investors is the IP. Without that IP, it's going to be pretty hard to be a commercial entity, especially if you're not focused on the government funds or agency funds. So if you're trying to raise money with VCs, it's definitely important to have an intellectual property. The stage that we're sort of heading at now is moving towards the prototype and demonstration stage. So one of the things is, I'm just going to go back to the other slide for a sec. So one of the things with our mission is it's a quite a large mission. So it's not just a single product that we're trying to build, develop, get it into space. The rover itself, with its payloads, has quite a lot of technology. A lot of that is new technology, and what we've noticed within the space industry is when you're developing new technology for space, you're actually able to tech transfer that to Earth, and there's a lot of different applications, and a lot of industries are very interested in that technology. So just as an example, one of the first technologies that we're actually looking at commercializing won't be in space, but it will dramatically increase the time to complete to increase our TRL for the space application. So our parabolic dish, for example, we have interest from 3 different industries, and looking at building that over the next and delivering it over the next 12 months. The benefits to focus on the terrestrial side, like in my view, it doesn't really take you away from the space aspect because you're still developing the technology and the product for space. And it increases the time frame to get to a high TRL. The only issues that we've seen in this model and the way we're doing things is that some VCs or some investors can portray what you're doing as spreading yourself too thin or doing too much. Most of that's in relation to the way that we present has to be very precise. They have to understand that the actual rover itself has all of these technologies that we're commercializing on Earth. So when you couple all of them together, you get the space mission. What we've found is a lot can't, like, or they just don't really see it in that way. And that's normally when the story's not all there, or they haven't got the full story. So the benefits of that is, of developing the product for Earth, is that we also get revenue, early stage revenue, which funds the space mission. I think space is becoming easier to raise funds, but it's still high risk. It's still long-term reward. It's a longer investment, and that's definitely very restrictive. The other way that we're doing the TRL increase side by commercializing the products on Earth is we're collaborating with development customers, and those customers are fairly high profile in their industry. So one of the big benefits there eventually will be the traction that we can demonstrate having delivered projects and products for some quite significant companies here on Earth. So if we can do it here, we should be able to repeat it in space. So that's basically just a different look at space industries and what we're doing. And that's pretty much all I have today. Thanks.
That was shorter than I was expecting. Yeah. That's good. That's good. No. Seriously, thanks for being up in the middle of the night for doing this. I know that's pretty uncomfortable. So appreciate that. So can you talk about some of your customer validation, right? So you didn't just jump into this for the fun of it. You weren't really a space nerd to begin with. Like, you've become one, but that's not where you started. So talk about how your process and your individual process and evolution to how you got here, and then how you justified the work to customers.
Yeah. So probably the easiest way to the path that led me to space would be the mining side. I like to do, and also my business side, I like to do projects that are meaningful, long-term, large projects. And when just trying to think the actual point where I did spot to space, and it was a long transition. It was a long thing. It was mining. I wanted to produce a resource that no one else could produce. And that's when initially we were just looking at helium-3. And then that obviously was the connection to space, being there's no economical resources to mine that here on Earth. So we had to look off Earth. Can we get it off Earth? And that was the lead there. And then obviously with the economic side, and the focus now is on the water, because that's the next 10 years will be a full focus on producing water in space. So on the work that we've done and validating that with companies that we're speaking to now, we don't really put too much out in the media at the moment, because we want to keep that sort of that bit of an edge. But we actually do a number of, or collaborate with a number of universities to validate our hypothesis on the water production side. So yeah, our look is the protons coming from the sun combined with electrons form hydrogen, the oxygen in the regolith, that's water, and then bonded with the silica. So we focus on the sunlit areas and being able to produce water in the sunlit areas. Yeah, that was the Sophia mission, helped us validate that in 2020. Around the same time in 2020, we also did ion implantation at the Australian National University. We've shot protons into regolith simulant and produced water there. So basically that whole side helped to validate the water that we're going for, or able to produce. We can also, our mining method can also produce from ice water in permanently shaded craters, but we wanted to make sure that we had the capability for being able to produce water anywhere on the lunar surface. So that's probably those tests and the way that we put that strategy together to tick all the boxes is probably one main point that we provide to customers we're looking to deal with. And then the collaboration with the universities helps give peace of mind. So I think we deal with about 4 universities currently through Australia, when we're currently looking to expand that over to the US as well. And then, yeah, I think that's probably the biggest point at the moment, given the stage that we're at. We're still got a few years left to go.
So all right, that's a good point, right? You're still pretty new, pretty young. The Australian government has only recently created a space agency. You're partnered with that. Talk a little bit about that. You're kind of in the vanguard of Australian space development. So what does that look like?
Yeah, it's Australian Space Agency's fresh.
Fresh, really fresh. Like,
yeah,
18 months officially. They've had a program for a long time. I mean, going back to the Apollo days, but as its own organization, I believe it's only like 15 or 18 months old. Is that right?
Yeah, I think they're a bit further, because I believe that their review process is starting soon. Once that completes, then they'll be their own agency, where they'll have more freedom to do missions and sort of larger side. So they've got a lot of programs out at the moment. We're collaborating with a number of companies that have received funding and grants from them, and then we're currently setting up to participate with the Trailblazer program that they're doing there. It's not when our business model isn't that we require to receive funding from them, but the Trailblazer program's $50 million for a national mission. Given that we are pretty much a mining and resources country, I think our mission's quite aligned to there. We're getting really good support on that side, and looking forward to seeing how that goes.
Let me dive into that a moment. Earlier this evening, early morning while you were asleep, there was a lot of conversations about how everybody wants government dollars, government dollars, government dollars. That's the only thing we keep hearing. And if this is going to be an industry, if the moon is going to develop industry, it can't just be a single client of some government agency. So you just said a second ago, you're not dependent upon this. So who are your clients? What do they look like? Just kind of characterize us, kind of characterize them for us.
Yeah, so each of the technologies that we're developing, we're setting up with development partners and looking to license out the IP for terrestrial use. The revenue generated from that should cover the costs. So that's relying on that side. And then the actual customers. So I can mention potentially a couple. With the 3D printer that we have, we've got interests from Schlumberger Oil and Gas. And then there's electric aeroplane companies interested to print aeroplane parts. And there's a few other companies. So that one there's more being set up initially as a service business, where we'll actually employ potentially 1 to 2 people. They'll run the printer and we'll run it as a service. So it's more, it's not as big a revenue, but it's consistent, decent production revenue. It also allows us to demonstrate manufacturing capability and manufacture parts for our lunar side of things. Then on the mining side, so for Earth, we call it the volcano process, because basically we turn the regolith ore here on Earth, we turn mining ore into molten magma, basically. So that one we targeted resource companies. One of the companies that we collaborated with on phase 1 in the lab, they're one of the top couple mining companies in the world. So we're pretty happy that we got them on board. In WA, there's a couple other companies that we're dealing with. So there's about 3 resource companies in total. I can't, because of NDAs, I can't mention who they are. But they're quite exciting to work with. I think because of my background in the resources industry, and because I've done so much in the resources industry, it's allowed me to really pinpoint the pain points for these companies and identify those. And then because of the current transition to going green and sustainable for mining companies in particular, they have a lot of interest in the technologies that we're doing, because it's sustainable, it's green, and it's space, which is kind of cool.
It's pretty cool. It's pretty cool.
So then we've got the solar concentrator. That one there will probably end up being the first to commercialize. And that one we've got interests from agriculture industry for powering sort of pumps. Even had a request for using it for desalination.
Oh, really? That's
yeah, that was good one. So a lot of the bore water in Western Australia is brackish, so there's a lot of salt.
Right.
So currently they run all these remote pumps. You got cattle stations that are super remote. Takes 6 to 10 hours to drive there. That's sort of remote. And yeah, they're pumping out brackish water and then running RO units and then filling up their tanks and stuff. So using our method, we can sort of speed up the process and just take it out of the sand as well in some locations in the desert.
Wow.
So we've had agriculture. We've got interests from relating to defense. We're actually in Washington on the 1st of the 4th for Sea, Air and Space event in Washington, DC. So we'll have a booth there at the Australian Defence Forces representing Australian innovation technology. Yeah.
That's
so that's where we're at.
I know that event. That's a pretty prestigious event. That's good. That's cool. So you showed your rover a minute ago. That rover is not a small rover. That is a beast of a machine. Can you talk about that? Or are you willing to talk about that a little bit?
Yeah, so that concept image is our evolving concept image, which goes to the public. Our actual rover, not many people have seen it, but we're almost in a position to
Let's be clear. There is an actual rover. You just showed a drawing of it. I know that's true. There is actually a rover that's driving around.
It's not driving around yet.
Can we see that image again, Joshua?
Yeah, one moment. I'll just see if I've still got it up. So we've got the mobility system from Maxon. Sorry, the drive system. We're just finalizing a few bits and pieces now on the design before we build the actual platform. So what we just try and go back. So what we are doing is skipping building an Earth or terrestrial rover. We're going straight to we're designing everything for the lunar surface straight away. It's still being designed to be able to operate here as well, under Earth gravity. So we've got all the parts, all the computer cables, the motors, everything. The only thing that's different with the space race system that we're getting, that we've got, so it's the same as the Mars rover, just with different gear ratios. That's the only difference. And then for the initial prototype, we're using planetary gears instead of harmonic drives, purely because of the cost side. But the actual motors are the same pancake motors used in most rovers. It's a large rover, so it's designed to be a tank or a bulldozer, not a scientific experiment. It's 2 meters wide, 3 meters long. It has a ground clearance, which is currently looking at about 0.75 of a meter, 750 millimeters. The body height itself is quite thin, sitting around about 0.5 meter. We're reducing that at the moment, which is good. Aiming to have 0.5 ton minimum of water capacity for storage. And then, the dish is just under 6 meters diameter for that. And that'll produce 40 kilowatts of energy on the surface. And then the mining method is 1 meter by 1 meter payload size. So with the Maxon stuff's already here, so we're just finalizing the mobility platform. So the way our rover is being designed is similar to the electric vehicle mobility platforms, and then just plump the car on top. So basically that's what we're doing, and we'll start the construction in August, late August, which is when we also launch or do the opening for our facility as well. So we've got that new facility with the clean room, which we can build the LREV, and then we've got another section in there which is can be used for other additional payloads. Advanced engineering office with a number of workstations. So we use CATIA, ANSYS, and a number of other softwares, fairly standard in the industry. And then we also have a remote operations office as well, with the RU, which is very Australian. And that will be used to demonstrate the remote operations of the rover. So a lot happening next month.
A lot. We do have to transition. For the record, I think I've had 3 scheduled meetings with Joshua that were like 30 minutes each, and each time our 30-minute meeting turned into 90 minutes. So like every time I talk to this guy, I just want to keep asking him some questions. But we do have to move on. Joshua, go back to sleep. Really appreciate you being here this early in the morning. I know you're going to stay at the office. I know we already talked about that. But thanks for joining us.